Okay, this one might be kind of a long one. We'll see. I want to do another class example, and I want to extend the idea of overloading that we talked about when we talked about constructors to methods in general. So I want to create a class that has not just an overloaded constructor for the class, but has a couple of overloaded methods. And I thought that I would use the simple example of a car as my class. So I've created my outline for a class here. And just thinking about what kinds of variables you would need to describe a car. Make and model, year, the odometer, how many miles it has on it, the fuel tank, how much the fuel tank holds, how many gallons it holds, and then the fuel level, how many gallons are currently in the tank. And then the mileage that the car gets, that I'm just putting in as miles per gallon. So that's what, 1, 2, 3, 4, 5, 6, 7 instance variables, which is a lot. And that means when I call the constructor of this car class, when I want to create a new car, I have to give it 7 values to put into those instance variables if I want to create it full of variables. It also means if I want set and get methods for all of the variables in the class, that I want to have 7 set methods and 7 get methods. Do I, though? Do I need set and get methods for everything? We think about a car. Once you create an object called a car, you might not want to ever imagine changing what kind of car it is. I drive a Hyundai Tucson. It will always be until the day it dies a 2015 Hyundai Tucson. So I don't really need set methods for the make, the model, and the year, because those things never change. So when I create my set methods for this class, maybe I will only create set methods for the odometer, the fuel tank, the fuel level, and the miles per gallon. So if you can imagine a situation where you absolutely positively do not want the value of an object's particular variable to ever change, don't make a set method for it, because that's just, first of all, it's making trouble. It's putting code in your program that doesn't need to be there. But second, it's leaving open the possibility that something might change that you don't ever want to change. So I can have set methods for only some of the variables of a car. And I just copied and pasted them so you didn't have to watch me type that all over again. Again, when I do my set and get methods, I like to put them on one line. And sometimes I like to not only put them in one line, but I like to tab over to line up the curly braces so everything looks nice. Same for the get methods. Okay, I want to create get methods for every one of these instance variables. Maybe I'm going to copy and paste them again, so you don't have to watch me type a bunch and make a bunch of mistakes. What might I want to find out from the outside? I might want to know the make, the model, the year. So I've got a get method for the get make, get model, get year that returns that instance variable. You might imagine that you don't want the car to ever have its odometer changed from the outside. Right? When does a car's odometer change? It happens when it drives. Maybe drive is a method of the car class. You don't want someone from the outside changing your odometer. That's illegal. It's illegal to change the odometer of a car in any other way than driving it. So maybe odometer doesn't get a get method. You can only find that out from, you can only find out that value from inside. Maybe it doesn't have a set method either. Okay? The only way the odometer will ever change is to have the car's own methods driving change that. Likewise, maybe the fuel level. You only want that to change via a method of the class. So you can think about when you make your classes, which things do you want to be able to get from the outside, which ones do you want to be able to set from the outside, and so on. So those are my set and get methods. I always put them at the bottom. Sometimes I'll even do this. Set and get methods below, just so I don't have to look at them. And then I'll Move them way down there so I don't have to bother with them. Okay, once I create them. Now I'm going to make a constructor for the car class. And I'm going to make a parameterized constructor that takes all of the parameters for all 7 instance variables. And again, I'm going to copy and paste this so you don't have to watch me type it all. What do I need in my constructor? I need public car, which is the name of my class. And then in parentheses, I need all of those parameters. Something that I will sometimes do, and I'm not sure this is considered good Java form or not, but I will do it sometimes. Since Java doesn't care about white space, I will put that parameter list all in separate lines with returns in between them. So I can look at that and it's not just a big, long thing in parentheses that stretches off my screen that I got to scroll way over to find it. So these are my parameters for my constructor. I need a string to define the make, Hyundai, a string to define the model, Tucson, integer to define the year, 2015, a double for the odometer reading, 138,000 miles, a double for how big the fuel tank is, a double for how much fuel is currently in the tank, and a double for the mileage, how many miles per gallon the car gets, how many miles of gas it uses per gallon. So sometimes I'll do it like this because I think it looks nice and I can read it at a glance. It's actually really easy for me when I write my constructor to do it like this because I can see everything. But the normal way to do it, and I'll go ahead and shift to the normal way, is to just have all of these things separated by commas in a big long list of parameters. So I need an integer for the year, I need a double for the odometer reading, I need a double for how big the fuel tank is, I need a double for how much fuel is in the fuel tank. And now you see it's run off the screen, which is one of the reasons why I sometimes do it all in one line. And then a double, double for the mileage. And then I've got a couple of spaces I need in here, I think. And then my open and close brackets to actually write my constructor. Okay, so this is, I should put a comment here, constructor for the car class. Now, every one of these parameters that I pass to the constructor, I'm going to put into the appropriate instance variables: make, model, year, odometer, fuel tank, fuel level, MPG. Okay, so again, so as to save you watching me type, I'm just going to paste that in. Okay, so the parameter that I pass to it is make with a lowercase m. I put that in the instance variable called make. Model, I put into model. Year, I put into year. Odo, I put into odometer. Tank, I put into fuel tank. Level, I put into fuel level. And MPG, I put into MPG. And I've used the convention of making the parameters lowercase and the instance variables uppercase. There are all sorts of different ways to do this. And that should do it. I should be able to create a new car by calling this constructor. Let me click save, go to my main program, and here we go. Car, my car is the name of the variable, equals new car that calls the constructor of the car class. And now I have to give it all of these values. And I have to kind of remember what order they're in. It wants make, model, year, odometer, fuel tank, fuel level, MPG. I might have to go back and forth a couple times if I forget that. In fact, I could just copy this and move it over to my program. Okay. And paste it here. Just just do this so I can remember for myself what those instant variables are. Okay. Maybe not necessary if you've only got 2 or 3 instance variables, but if you got 7 and want to remember what they are, you can just create yourself a little cheat sheet in the comments. That's what comments are for. Okay, so my car equals new car. What does it want? It wants make, Hyundai, model, Tucson, year, 2015, odometer. I think my car's got about 138,000 miles on it right now. Fuel tank, I don't know how many gallons of gas it holds. Let's say 15. Fuel level. When we create a new car, let's create it with an empty gas tank. Okay, so the fuel level is 0. And the miles per gallon, I don't know how much I get. Maybe 25 miles per gallon, average. Okay. I spelled Hyundai wrong. So if I run it now, we're just looking for mistakes. The program doesn't do anything. It makes a car. Oh, look at all those errors. Where are my errors? Car.java 15 is probably something really simple like a missing brace. 15 public car. Double, double, double. Interface or enum. Where's my mistake? Oh, my mistake is I've got a bracket in here that's supposed to go at the very, very end of the class. I pasted my constructor outside of the class instead of inside of the class. So Java was confused because I ended the class and I had a bunch of crap in there because it was outside of the class definition. So that was just a silly mistake. But it's important to know what these silly mistakes are. Sometimes I debate like how clean these videos should be. Should they be perfect with no mistakes in them? If they're perfect with mistakes in them, then you don't get to see the kinds of dumb mistakes that you could make, like accidentally ending your class before the constructor. So that's a dumb mistake that's important to know how to do. You just gotta have your brackets in the right place. Okay, so what happened? When I run it, all it does is print car class example. That's because all my program does is print car class example. It makes a new car and it doesn't do anything. I could print out the information on that car by getting the make, getting the model, getting the year, and printing them out in the main. Much better to have a method that belongs to the car class that prints out all of its information. And again, I'm going to copy and paste this. I'm going to create a method called display car that just prints out all the instance variables in a nicely formatted way. So I'm going to call it display car, and it's just going to be system out print year plus make plus model with plus odometer, miles, fuel level of fuel tank, gallons filled, MPG plus miles per gallon. Just all of those instance variables with some words in between so it makes it legible. So if I want to know the information about a car, I have to ask the car. The car owns its display method. And so if I want to display the information of the car I just created, I type my car, the object, dot, display car, its method. Notice that this method, display car, is of type, where'd it go? It's public, so I can call it from outside the object, but it's void because it doesn't return any values. It just prints stuff. It just does stuff. So anytime your method just does stuff, it doesn't come back to main with a value, you make its type class void. So now let's run the program. Now it should do something. It creates the car, and then it prints out the information about the car. 2015 Hyundai Tucson with 138,000 miles, 0 of 15 gallons filled, so the tank is empty, and it gets 25 miles per gallon. Okay, so that is my car now constructed with a constructor, and it has a method to show us all of its stuff, all of its instance variables. Let's overload that constructor by creating a version of it that just creates a generic car. I can't do that now, right? If I try to create a generic car by creating a second car, my other car equals new car. If I try to call that constructor with an empty parameter list, I will get an error. It will say that the types don't match. What's my error? Constructor car and class car cannot be applied to given types. My other car equals new car required. String, int, double, 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 double. Found, no arguments. So I can't call the constructor with no arguments because I created my own constructor. If I want to be able to do that, I've got to create another version of the constructor that has no arguments. So let's do that. Okay, let's overload our constructor by creating another version of it. And I'm going to, again, copy and paste so you guys don't have to watch me type and make mistakes. So this is the, and now I'll call the first one, this is our parameterized constructor of the car class. And then I'm going to call this the generic no parameter constructor of the car class. So what does it look like? It starts the same public car, but I've got a completely empty parameter list. I'm not passing this version of the constructor anything. So I just want it to assign generic values to the car. So the make is generic. The model is model. The year is 1900, pretty close to the first year that you could ever buy a car. The odometer is 0, it hasn't been driven. The fuel tank is 20, that's just a number I picked out of thin air. The fuel level is 0, it starts with an empty tank, and the mileage is 30 miles per gallon. Again, just a random value that I chose. So now I can create a sort of an empty car, a generic car, that has these particular default values that I have chosen. Okay? So I've overloaded this class's constructor by giving it two different constructors, one with parameters, one without parameters. Now I should be able to, if I did not make any mistakes, go back to my other car and create it by calling this empty version of the constructor. My other car equals new car, no parameters, which means that I should be able to display its parameters by calling its display car method and see that it's filled with those generic values. Let's run it and see. Oh, semicolon in line 25. Where are you? Right there. Last thing I typed. Okay, so here's the first car, the 2015 Tucson. And then here's my car that I created by calling that parameterless version of the constructor. And so that version of the constructor gives my other car these generic values, generic model with 0 miles, 0 gallons of gas in the year 1900, like a Model T Ford. Okay? I can do this as many different ways as I like. I could create a partially parameterized version of the constructor that just takes the make, model, and year and puts in generic versions for the odometer and the fuel tank and the miles per gallon. Maybe it's not worth the time to do that right now, but I could do that right now. Okay. So I've got my, let's go back to my car class. What have I got? I've got my class definition. I've got my parameterized constructor. I got my no parameter constructor. I've got my print method. let's create a method that does something. What do you do to a car? You drive it. Okay. So what's the drive method going to do? It's just going to be a void method. It's going to do stuff. It's not going to return anything. So it's going to be public void return type drive. I'm going to make it just take no parameters. Okay, it just does something. What does it do? It's just going to print something. Let's just print. Let's go vroom vroom. Okay, so the car is driving. Got too many brackets in there. I think that's right. System out print line. Let's go vroom vroom. Okay, so the car is driving. Let us go back to our main. Let's kill my other car for now. Well, let's not get rid of him. Let's comment him out. Oops, got rid of him by accident. Get rid of my other car. Move him down the screen so we don't have to look at him. And let's drive my car. So my car equals new car, blah, blah, blah. Now I'm going to drive it. My car dot drive, no parameters, semicolon. And the drive method just prints, let's go vroom vroom. So the car is driving, but it's not really doing anything, right? It's not doing anything to itself. It's not doing anything in the program except just printing a statement. What happens when you drive a car? You go a certain amount of distance and you burn gasoline. Okay? You use up some of the fuel in your fuel tank. And the amount of miles you get tells you how much gas that you use. So let's write a method that actually drives the car a certain distance. So this is a sort of generic drive method that doesn't do anything. And this is a drive method that drives the car some distance. What distance? We'll make that distance, should we make it an integer? What did I do before? I'm going to cheat over here and look at the version I wrote before. Yeah, let's just make it an integer. We can make it a double, but let's just make it an integer number of miles. Some distance. So instead of having an empty list of parameters here, I'm going to give it a distance. So now I have two versions of the drive method. One doesn't take any parameters and doesn't do anything but print. The other one, if you tell it the distance to drive, it's going to do some different stuff. What stuff should it do? It can still print vroom vroom if you want. It can print we drove a certain number of miles. Right? We drove distance miles. Should I make that distance capital or lowercase? I got to decide. Let's make it uppercase. Okay. So what happens when you drive some distance? Well, you should change your odometer reading, right? When your car drives some distance, it should change its odometer. So the new odometer reading is equal to whatever the old odometer reading was plus the distance. Update your odometer. Okay. What else should you do? You should use some gas. So how does that work? Your fuel level is going to change, right? I call that variable fuel level. And it's going to be equal to whatever it was before minus the distance you travel, distance, divided by your mileage. Okay. Use some fuel. So your fuel level will change by the amount of the distance you drive divided by your mileage. And then maybe we'll print out our fuel level. We'll do a system out print line system out, print line, fuel level. I don't know why this keeps scrolling over like that. It's really frustrating. Fuel level. Let's see, plus gallons of gas left. Okay. Period. End. Okay. So this is our drive method. I give it a distance. It drives that distance. It updates the odometer by that distance, and it burns the appropriate amount of fuel. Let's see if it works. Instead of calling mycar.drive the empty method that just prints vroom vroom, let's drive 100 miles. Run. Let's go. Vroom vroom. We drove 100 miles. -4 gallons of gas left. Why -4 gallons of gas left? Because my car started with 0 miles. Sorry, 0 gallons of gas in it. We got to fix that. We can't let that happen. We got to stop driving when we run out of gas. We should also print out the new odometer reading. So let's do that. Where's my method? It bothers me that when I jump from one file to another in code HS, it doesn't put me back to the last place I made changes. I wish it did that. We drove blank miles. Let's put it here. The car has driven space plus odometer plus quote space miles total end quote end parentheses semicolon. Okay, so let's make sure the odometer reading gets updated. Oh, it didn't. Why didn't it? Oh, because I put the print statement before I updated it. Let's change the order of these little tiny mistakes. Update the odometer, then print the new distance. Let's go, vroom vroom. We drove 100 miles. The car's driven 138,100. Notice it was 138,000, so it did update. -4 gallons of gas left. How do we fix that? Well, we have to make sure that, well, let's just do something simple like, well, let's do this. Instead of printing how much gas is left, let's do this. If fuel level is less than 0, then print, oh no, we ran out of gas. Else, print, our car has fuel level gallons of gas left. Okay, so we'll put an if statement there that that at least engages if the fuel level gets less than 0. So let's run it now. We drove 100 miles. The car has driven 138,100. Oh no, we ran out of gas. Okay? Why does the car run out of gas? The car ran out of the gas because when we create a new car, the gas tank is empty. So let's create a new method called refuel that fills up the gas tank. Okay, so here's our drive method. We're going to create a new method. Add some spaces in here so we can scroll up a little bit. We're going to call that method refuel. Public void refuel. No parameters. And this is going to be a method of the car class that completely refills the tank. Okay, so the refuel method fills the gas tank completely. Not even close to how you spell refuel. So public void refuel. I like to make sure that anytime I have a method, it prints something, at least when I'm first writing the program and debugging it. It prints something so that I know it's been activated and the call actually worked. So we'll print fill her up, semicolon. And then what does it mean to fill the tank? It means that the fuel level should be equal to the fuel capacity, which we called fuel tank. Okay. Yeah, and I think that's all that method needs to do. Now, let me save. I haven't saved in a while. Let me go to my program, and before I drive the car, I refuel the car. Now, it shouldn't run out of gas if I drive at 100 miles. Last time, it ran out of gas because it started with no gas in it. This time, it should start with a fuel tank, so I should be able to drive 100 miles without running out of gas. Let's run it and make sure that works. Fill her up. There's the call to the refuel method. Let's go, vroom, vroom. We drove 100 miles. The car is driven 138,000. Our car has 11 gallons of gas remaining. So it updated correctly the amount of gas in the fuel tank. Good, that works. Let's overload the refuel method too. Let's create another version of that refuel method. Sometimes we don't want to fill our gas tank all the way. Sometimes we can't afford to fill our gas tank all the way. Sometimes we only put $5 or 5 gallons of gas in our car. So let's create another version. Where'd it go? Of the refuel method. The refuel gallons method fills the gas tank partially. Okay. So now we create, should I make this an int or a double? What did I make it my sample version? I did. I made it an int. Doesn't matter. Now we create a version of the refuel method with the same name, but instead of just passing it an empty parameter list, we pass it a number, and that is the number of gallons to put in. Okay, so we're not filling it up. Okay, we are adding a number of gallons equal to fuel tank plus gallons. Okay. So now we're adding this variable that we've passed to the refuel method to our fuel level. Now that's not going to cut it, right? Because if we do that, it'll let us put 100 gallons of gas into a 10-gallon tank. So we've got to have some if statements to make sure that we're not overfilling the tank. First, let's just put a print statement here. Again, in the early stages of writing any program, I like to put a print statement in pretty much every method, even if it eventually isn't going to need it, because I just like to know that something's happening. So I'll put a print statement that says adding however many gallons I pass to the method, gallons of gas. And then fuel level equals fuel level plus gallons. But I can only do that if it'll take that much fuel. So I'll do something like this. And again, I will copy and paste this so you don't have to watch me type a bunch of stuff. I'll say if the fuel level plus the number of gallons is greater than the fuel tank. In other words, if I try to put more in the tank than it will hold, simply print the tank is full and then print only fuel tank minus fuel level gallons were needed. Okay. Does that make sense? If I'm trying to put more gas in than the tank will hold, just say, no, it only needed this much. And then now the tank is full. Else, If it's not too much to fill the tank, my brace situation here is going completely haywire. Else, line up that if and that else, the fuel level equals the fuel level plus the gallons, and our car has fuel level gallons of gas remaining. Okay, so that allows me to not fill it up all the way. Make sense? Let's try it and see if it works. So now, instead of, and there's a very good chance I'm missing a bracket here somewhere, but we'll see that when we run it. Now, instead of refueling it all the way, let's just refuel it with 8 gallons of gas. Okay. So now, this is calling a different method than it was before. Or rather, a different version of a method that I've overloaded by having multiple versions of that method available. So let me run it now. So I create my car. It's got 0 gallons of gas when I create it. I add 8 gallons of gas. 8 gallons of gas remaining. Let's go. Vroom, vroom. The car's written. And now it has 4 gallons of gas remaining. That makes sense because it gets 25 miles to the gallon, right? So if I drive 100 miles, that's a gallon of gas. It works. Let's try to overfill the tank to make sure that isn't allowed. It's got a 15-gallon tank, so we'll try to put 20 gallons in it. So I'll call refuel the refuel method, giving it 20 gallons of gas. When I run that, it will say, adding 20 gallons of gas, the tank is full, only 15 gallons were needed. So that works too. Okay. If I, let's see, let's give it 10 gallons to start. And then when we're done, try to put 5 gallons in it. Adding 10 gallons of gas to the car. Our car has 10 gallons remaining. We drove 100 miles. Blah, 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 blah. Our car has 6 gallons remaining. I tried to add 5. Our car has 11 gallons of gas remaining. Does that work? 6 remaining. Add 5. 6 plus 5 is 11. Still less than 15. It seems to be working. It seems to be doing all the right stuff. Okay? So what we've seen in this example is that not only can I overload a constructor by creating multiple versions of it with different parameter lists that fill different numbers of the instance variables, I can create methods with different parameter lists, one with an empty parameter list, one with an integer that's being passed to it, that do pretty different things, but have the same name, so that the structure of my class is simpler. I don't have to have a method called fill tank all the way and a method called fill tank part of the way. Right? I can distinguish the two behaviors with the parameters that I pass to the method. Okay, and again, that process in Java is called overloading. We have overloaded the refuel method by giving the program multiple versions of it that have different parameter lists and do slightly different things. And we can imagine a lot of situations that this might be useful. Last semester in the Python class, those of you who took that class with me, we wrote a tic-tac-toe game, right? And we wrote a version where a human can play against a human, and a human could play against a computer. And I think we had a method called human move and a method called computer move. We can imagine that we could write that tic-tac-toe program with one method called move, that if I gave it no parameters, it understood that means make a computer move. And if I gave it the name of a player, it would understand that that would be a human move, which is something different, right? When the human moves, you ask them for the move. When the computer moves, you choose a square yourself. So you can use overloading to make the functionality of the object depend on the list of parameters that it's given. And these are kind of silly do-nothing examples for now, but as we go on further and further, hopefully we'll get to see some examples where you realize, oh, it really makes it simpler to think about this method having one name but doing different things depending on what you give to it from the outside. Okay, so that's overloading.